So my name is, I'll write it up. My name is Carrie Olasak. And the problem I was assigned was example 3, 1.6. So my first problem I'm supposed to evaluate is evaluate the limit as the limit x approaches -1 from the right side of this equation, square root of x plus x minus 1 over x. So when first looking at a limit problem, I like to know what kind of limit I'm looking at. Is it a double-sided limit? Is it the right side or the left side? And so from this, I can see it's approaching, they want me to look at approaching from the right side. And on a number line, I'll show. So with -1, and let's say 0 and -2, what that means is the function, they want to know what the function is doing when it approaches -1 from the right side of the x, like this number line is representing x values. So they want to know from the right side, what is the function doing? They don't want to know about the left side. All they care about is the right side at -1. And so the next step would be to plug in the value to know if you're going to get a number over 0, a 0 over 0, number over number, or 0 over number case. So I will do that. So I will take square root of x, and now plug in -1 plus 1 minus 1 over -1. Sorry, that one looks gross. So after doing this, I will simplify. Well, hold on, let me fill in this. Function approaches -1 plus. So next, I need to simplify this problem. So limit of x approaching, I didn't write that correctly. So limit approaching x -1 from the right side would be -1 plus 1, we know, is square root of 0, minus 1 over -1. Well, we know the square root of 0 is, let me move this over so we can, it's going to be 0 minus 1, and that's going to be over -1, that negative sign. It's kind of going crazy. So then that, keep simplifying it down so we get a better picture of it. And it's going to be -1 over -1, which a negative divide, whoops. So a negative divided by a negative will equal positive. And so -1 divided by -1 will be 1. So the limit of this function up here when approaching from the right side of the x-axis will equal 1. So that will be our answer. So for my next problem, and in the end we saw that we'll note that this was a number over number case because we simplified it down, meaning we don't have to do any more work. This is good. We didn't have to keep evaluating the problem. Now for this problem, it's asking true or false if the limit approaches, as the limit x approaches 0, will the absolute value of x over x equal 1? So already I know from this problem it is asking me for a double-sided limit. So it wants to know on a timeline 0, -1, 1, +1. You know, this is like, you can think of this as the x-axis. When the function is approaching from the right and the left, what is happening at -0? And from this problem, it's saying it will be at, if we're going to add in the y-axis, at something's going to be happening at 1. So if this was 1. So they want me to, they're asking if it's true or false. Will this function equal 1 from both sides. So first, like we did in the top problem, let's plug in 0, the absolute value is 0 over 0. So the function's saying 0. This already know with red flag. It's a 0 over 0 case. So that tells me that there needs to be more work done. We need to evaluate both sides of the limit. Now, already I know this is the absolute value right here. And so they need to be evaluated differently. And so let's look at the definition of an absolute value. We'll include that at 0. So the absolute value of x is equal to, there's two parts to an absolute value problem, because you want to know as x is greater than or equal to 0, and then when x is going to be less than 0. Those are the two cases we want to look at with an absolute value problem. And we know from this that that means the x needs to be positive, so that's what x will end up being. And then for this one, the x value needs to be negative x. And so to give a little more insight, this will be the right limit, and this one will represent the left limit, being that this negative x is approaching from the left and then x will be approaching from the right. Because again, we need to look at both sides to see if this is true, that both of the limits will approach one, or if it will. So then we will then evaluate as the limit. We'll look at the right limit first. X approaches 0 from the right. You will get, we'll use the x. You'll get positive x over x. What will that be? I'll get another color out. These values will cancel. And then this will end up being 1. Great, so that means, that's awesome, that the right-hand limit will equal 1. So far the problem is correct. But we need to look at the left-hand limit also, because we need to know what the function is doing at the left-hand side. So let's do that. The limit of x over 0 for the left-hand side. No, sorry, as the limit x approaching 0 from the left side. Sorry. We will use negative x over x. And what will that equal? Well, these values will cancel, but we have a negative sign. So that means it's going to be negative 1 over 1, which means it's going to be negative 1 overall, which is not good because it's not equal to 1. So that tells me that the function, I'll draw a little picture of what the function is doing. So we're 0 right here. We want to know the x value, 0, what is it doing there, what the function is. So the right-hand limit, this is 1 and this is negative 1, that the function is heading towards the 1. But from this problem, what we solved and realized is that from the left side that this function is going in this direction. So that tells me that the limit for this problem does not exist, because this is undefined. We already know this is undefined. But yeah, this does not exist because the limit, the function is approaching at 2 different spots for x approaching 0. If it was just asking for the right hand or the left hand limit, we would have a different story, but since it's asking for what's happening at both sides of the limit, this limit does not exist. And so from is it true or false, this will end up being false because both of the limits from both sides, the function is not approaching 1. So there. Thank you.